studying water treatment in developing countries. How many of you would like to swim in this yellowish looking water that I got from the Scarsdale Middle School drain? I guess not many of you. Well, guess what? People in developing countries have to drink water which is much worse than this, which can eventually lead to diseases like diarrhea, cholera, and dysentery, if that is the only water available. I've decided to study water treatment in developing countries because this is a horrible crisis and I want to do something to help. To solve this problem, a lot of different products like electric, even ceramic filters have been invented. Clean water is a basic human right. Water is vital to sustaining life, human health, agriculture, power generation, and the list goes on. Did you know that 62% of the human body is water? In September 2015, 193 countries of the United Nations adopted 17 sustainability goals to achieve globally by 2030 relating to poverty and well-being. Number 6 on the list is clean water and sanitation. Even though 70% of Earth's water is in oceans or salt water, which is expensive to clean, so that leaves only about 2.5% of water for salt water. And of that fresh water. And of that fresh water, most of it is in glaciers or ice caps or groundwater. This leaves only about 0.01% of water for normal drinking, which is for surface water, which is in lakes and rivers, and it's contaminated, so it has to be cleaned. This is also the water we drink. So this is where people in different countries in US, India, and Africa get water from. In the United States, 75% of the people get water from surface water or reservoirs, and 25% of the people get water from groundwater. In India, as you can see, 85% of the people get water from groundwater, and this is a problem because the groundwater is being used too much, and this can cause depletion of the aquifers. And 15% of the water they get from surface water or reservoirs. In Africa, 77% of the people get water from surface water, which is very dirty. That's the problem with that. And 9% uses groundwater, and yet. So here are some important statistics about the water crisis worldwide. 1 in 9, or 844 million people, don't have access to clean drinking water. That's almost 2.5 times the population of the United States. Even worse, 1 in 3, or 2.3 billion people, don't have access to a decent toilet. Every 2 minutes, a child dies because of unclean water or poor sanitation. And women and even children have to walk 3 to 10 hours a day just to get clean water for their families, and this water is not even clean. And this can take up a lot of their time, so children can go to school and adults can earn money for their families. This map shows where the problem is most severe by percentage of the population, and as you can see, Africa has the worst problem, with 32% of its population without access to clean drinking water. Here I also put on the map the top 10 countries with the worst water problems. As you can see, number 1 is India, and in India, 40% of the people get water from the Ganges River, even though it's one of the most polluted rivers in the whole entire world. Also, 70% of untreated sewage water gets put into oceans or rivers without being cleaned. And only 50% of India's population gets piped water. Another country I want to point out, which is number 5, is China over there. And China is polluted because of the high industrial activity. I also put in this map to show that not only Africa is the only problem with the water quality problem, but also most of Asia, Australia, South America, and Mexico, and southern United States have water problems too. So these are some 4 main categories that water contaminants can fall into. Biological contaminants like bacteria and viruses, there's chemical contaminants, physical and radiological. As you can see, this is a pie chart and it shows how contaminants can get in water. 30% is by untreated sewage, 20% is by farm runoff or agriculture, 20% air pollutants, 10% maritime transportation, 10% industrial wastewater, and the remaining is offshore oil and litter. I spent a lot of my time researching the common water treatment methods and their advantages and disadvantages. So you can boil, as you can see, this is boiling water. You can boil water for about 3 to 5 minutes, and this will remove bacteria and viruses. The problem with boiling water is that the energy to use it can cost a lot in rural areas, and it does not remove turbidity, chemicals, or odor. Another simple method is called chlorination, and you can just put chlorine tablets in water, and it will remove bacteria and viruses. The other problem with this is that it can produce harmful byproducts, and it can produce harmful byproducts and the water has a bad taste. Flocculation is a method which is used in most water treatment filtration plants, and this is a process where you can add chemicals such as aluminum salts, and they have opposite charge of the suspended contaminants in water. And as you know, opposites attract, so the contaminants stick together to form microflocks and eventually flocks. And the process of the contaminant settling is called sedimentation. This process allows the contaminants to be more easily removed from the water. Another very popular method is called reverse osmosis. This is a method where you apply pressure to dirty water on one side, and clean water goes through a semi-permeable membrane, but the contaminants get blocked. Most of the contaminants get blocked by the semi-permeable membrane. The disadvantages of this is that it requires maintenance, and also and the turbidity must be low in order for it to filter. Slow-sand filters consist of a layer of gravel and sand and is put in plastic or concrete containers. The key to this method is gravity, which makes the water come down through all the filters. The problem with this is that it is slow and it does not filter viruses. The UV or ultraviolet light and the ozonation method both remove a lot of bacteria and viruses. Ozone is one of the strongest oxidizing agents, except it can cost a lot. And UV is a process of shining a special kind of light through water, and this can filter bacteria and viruses. The problem with this is that it does not remove toxic chemicals, and it is not effective in muddy water. There's ceramic filters, which cannot filter viruses, desalination, which can harm marine life because it's disposing concentrated salts back into the water, and there's solar water disinfection. The light straw which I have here is a simple method. It does not require electricity, and it is very cheap, and you can drink it straight from surface water. Like I can drink straight from this water, and then the water will be clean before it reaches my lips. The Living Guard system is a reverse osmosis-based system where it uses the antimicrobial textile membrane to filter the contaminants. This process removes about 99.999% of all contaminants in just 10 minutes, and it costs $15 to $20 per unit. The sunscreen is a solar water treatment method, and also you can use ceramic filters in rural areas. Oh, and by the way, these are some effective water treatment methods that can be used in rural areas. Borewells and pumps both use groundwater, but there are two main problems with this method. One problem is that if it's used too much, it can cause depletion of the aquifers. The other problem is that the groundwater is starting to get a little bit dirty. And rainwater harvesting is a process of storing rainwater by building dams and reservoirs. I feel that this should be a key focus of the government, as this water is much cleaner than normal surface water. Did you know that New York gets most of its water from the Catskill reservoirs? The main problem getting clean water in developing countries is the lack of infrastructure. Governments need to infrastructures like pipes, reservoirs, dams, bathrooms, water treatment plants, and wastewater treatment plants. The governments need to prioritize giving the citizens this basic right of having clean water. Not only will this help the quality of people's lives, but studies also show that every $1 invested in water and toilets returned an average of $4 in increased productivity. As you can see, international communities can provide funds and help implement best practices. That's what international communities can do. Companies can help with safe disposal of waste. They can reuse water, and they can donate to water charities. And individuals can also help by conserving water. They can not pollute, and they can educate. As you can see, an average African only uses about 20 gallons of water per day. They compare to an average American who excessively uses 100 gallons of water per day. I went to the Millwood Water Filtration Plant, which is a world-class facility, and the plant manager, John Young, showed me how the water came from the Cascade reservoirs, went through the aqueduct, and came into the plant through gravity. He also showed me the 5 main steps: coagulation in 2 rapid mixers, flocculation in 3 tanks, dissolved air flotation, ozonation, and filtration. And this is the video of the sludge removal after the coagulation and flocculation.
But the most important thing is that they're air bubbles, right?
You can see that
Sludge. Only 95% of the sludge before it goes to filtration.
As you can see, the sludge was being removed, and those were like the microflocks and the flocks using the dissolved air flotation method. So where the air bubbles make the contaminants go to the top. I also went to the Austin Water Filtration Plant, and the plant manager, Steve Ho, showed me how they had similar steps to the Millwood Water Filtration Plant, except that they did not have ozonation or dissolved air flotation. Also, this plant had a backup reservoir on site. I interviewed Brenda Smith, a PhD student working at the Grossman Group in MIT. He was developing nanofiltration membranes, which was very cheap and used for household water treatment in India. Nanofiltration is like reverse osmosis. It's a membrane filtration method like reverse osmosis, except that it has bigger pores, and so it allows the mineral to go through. I also interviewed Ritik Sharma, who works for Yes Bank in Mumbai, India. Yes Bank is installing living guard water filtration systems in more than 600 railway stations in India. These methods do not require electricity. Last, I interviewed Pai Patel, CEO of Summit Chemicals in New Jersey. He gave me samples of aluminum chlorohydrate, which can be used for coagulation and flocculation. In my house, I did some simple experiments, and I measured the TDS, or total dissolved solids, of these different types of water in ppm, or parts per million. Also, I built this filter, which contained a coffee filter and cotton balls to stop the activated carbon from coming in the water, and also to remove the odor. I had activated carbon staying in zeolite too. I used this filter to filter the Scarsdale Middle School sewer water, and the TDS reduced significantly to 137 ppm. But the TDS of this was still higher than the Scarsdale tap water. I learned that these homemade water filtration systems require a lot of maintenance and measurement. I also learned that the centralized water systems are more effective and efficient than normal homemade experiment methods, like the centralized water filtration, like water filtration plants. The water infrastructure has not kept up with the growing demand. By 2030, expecting no change in growth, there will be 40% gap between global water supply and demand. I'm going to go to India this summer, and I plan to visit some rural areas and help donate some effective water treatment methods to educate them about water treatment plants and raise some money from companies. We can all do our part by helping this crisis. We do not want to fall victims to the lack of potable water. The poem, The Rhyme of the Ancient Mariner, warns us, water, water everywhere, nor any drop to drink. For more information about my topic, scan this QR code or visit this link.